So in this video, we want to talk about equations of ellipses in 2D and 3D. Let's start with this equation, x minus 2 to power 2 divided by 9 plus y plus 1 to power 2 divided by 25 equal to 1. This is the equation, plus 1. This is an equation of an ellipse in a standard form. What is the standard form? Standard form is a complete square plus another complete square equal to 1. If I want to graph this, this is an ellipse, center 2 and -1. So I can draw this 1, 2, -1. And that's the center. And then in x direction, 3 to each side, 1, 2, 3, 1, 2, 3. And in y direction, 5 to each side, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And so this is how this ellipse approximately looks like. Doesn't look very ellipsy at the moment, but you get the point. Now, when I'm trying to parameterize this equation in 2D, it's always complete square plus complete square equal to 1 always reminds me of cosine squared t plus sine squared t equal to 1. Now, my next thing is that so this is going to say that that's going to be cosine squared t, this is going to be sine squared t. Basically, I have to solve from here. Cosine squared t equal to x minus 2 to power 2 divided by 9. Sine squared t equal to y plus 1 to power 2 divided by 20. And from here, I want to solve for x and y because I'm parametrizing for x and y. So from the first one, let's take the square root of both sides. I get x minus 2 divided by 3 equal to cosine t. I don't need to put plus and minus because t can run between 0 and 2 pi. And I get the minus values in there as well. And so solving here gives me x minus 2 equal to 3 cosine t and x equal to 2 plus 3 cosine t. And over here, if I take the square root again with that same argument, it's y plus 1 divided by 5 equal to sine t. So y is equal to y plus 1 equal to 5 sine t, then y is equal to 5 sine t minus 1. Now I'm writing the parameterization as x equal to 2 plus 3 cosine t and y equal to 5 sine t minus 1. I want you to notice that the center appeared in here. That center that you found appeared right in here, basically. And that's my equation. I do like to write this in the vector format. And the vector format is going to be 2 plus 3 cosine t and 5 sine t minus 1. Now let's talk about this equation. Equation of the same thing. In z equal to 7. So it says that there's an ellipse that lives in z equal to 7. In future, you will learn that this is elliptical cylinder intersecting with z equal to 7, which is going to give you an ellipse. But here's the thing. When your x and y are related, so right here, basically what happens is that your perspective, when you project your shape to XY plane, this is still going to be the same ellipse that we got in here. So I still get, if I projected the projection in XY plane, still gives me that ellipse that I got a few minutes ago, approximately like that. Here's X, here's Y. So I still have what I got from the previous section. I still have X equal to 2, which is the center, X value of the center, plus 3 cosine t. Y equal to 5 sine t minus 1. The only thing is that Z is not involved in here. In fact, if I didn't have this, Z would have been a free variable. The only thing that I need to add is by intersecting it with Z equal to 7, I actually have Z equal to 7. So the vector format of that is going to look like this.